So today we'll be exploring chapter 5, discrete probability distribution. And here we are solving some basic problems on discrete probability distribution that will help you to solve every single problem from Math 135 from your mastery exercise. So here we are going to start with the first example. And in this example, let's see what is asked. Determine if the given distribution is a valid probability distribution or not. So we have to check here the distributions are given. We have to check whether these are the valid probability distribution or not. When I say a valid probability distribution, if you remember, it has to follow two things. That is, all the probabilities must be between 0 and 1. Okay, all probabilities must be between 0 and 1. That is the first condition. And the sum of all probabilities, if you add all probabilities, that must be equal to 1. So if these two conditions are true, then we say that it is a valid probability distribution. And we are going to check that for each of these. If you look at the first one, you can see the probabilities 1 over 7, 1 over 7, 2 over 7, 1 over 7, 1 over 7. These are all between 0 and 1. None of these is more than 0. Okay? I mean, none of this is more than 1. If it is more than 1, the numerator will be more than 7. You can even change this to decimal and check it. 1 over 7, 1 over 7, 1 over 7, 1 over 7, and 2 over 7. If you try to change this to decimal and check it, you'll see that all these probabilities are between 0 and 1. So that first condition is true. So for this, I can write here, the probabilities P of X is between 0 and 1. Okay, P of X is between 0 and 1. Now we have to add and check. If we add 1 over 7, you can see they have a common denominator of 7. In the numerator, we have 1, 2, 2 plus 2, 4, 5, 6 over 7. So the sum, you can see, the sum of P of X is 6 over 7. It is not equal to 1. 7 over 7 is 1, but 6 over 7 is not 1. So it is not equal to 1. So the first condition is true, but the second condition is not true. Is this a probability distribution? What do you think?
It's not.
It is not a probability distribution. It is not a probability distribution. So make sure you write the sentence. It is not a probability distribution. That is our first part, A. Now let's look at B. If you look at B,
It is.
here you can see all probabilities are between 0 and 1. So the first condition is true.
Yes.
So here, all probabilities are between 0 and 1. And if you try to add these probabilities, you can also add in your calculator 0.41 plus 0.10 plus 0.29 plus 0.20. What is that equal to?
1.
It is exactly equal to 1. Very good. This is equal to 1. Is this a probability distribution?
Yes.
Yes, it is a probability distribution. It is a probability distribution. I'm writing that sentence. Make sure you also write the sentence. Okay, let's look at C. In C, you'll see that all these probabilities 0, 1/4, 1/2, 3/4, these are between 0 and 1. So the first condition is true. Here, you can say P of X is between 0 and 1. P of X is between 0 and 1. And if you add, let's see, if you add all this, 0, then this is 1/4. Half can be considered as 2/4, and this is 3/4. So 4 is the denominator. If you consider this as 2/4, you have 2 in the numerator. So 2 plus 1, 3, plus 3, 6. 6 over 4, which is same as 3 over 2. So if you add,
1.5.
what is it? 1.5, that's right. Yeah, 3 over 2 or 1.5. And this is not equal to 1. This is not equal to 1. So is this a probability distribution?
No.
No, it is not a probability distribution. Let me write that. It is not a probability distribution. So the third one is not the probability distribution. Now let's check the fourth one. In the fourth, if you look at the probabilities, here you'll see that this probability is negative. So it is less than 0. So here, when the probability when x equal to 15, when x is equal to 15, you can see when x equal to 15, the probability is negative, which is less than 0. Less than 0. Probability cannot be less than 0. The probability must be between 0 and 1. This is negative. So is this a probability distribution?
No.
No, it is not a probability distribution. So you can write that. It is not a probability distribution. Write that sentence. It is not a probability distribution. Okay. Okay, second example. This is quite similar to what we have done in lecture earlier. In a lottery, the winning prize is 10,000. That is the winning prize. If each ticket costs $20 and exactly 500 tickets will be sold, find the expected net gain if someone buys one ticket. See what is going on here. They sold, you can see, they sold 500 tickets. And then the cost of one ticket is $20. But they are giving only one prize. Okay, they are giving only one prize, that is $10,000, just one prize. Meaning of that is they are selling 500 tickets, and out of 500 tickets, only one ticket will win, and remaining 400, 500 minus 1 is how many? 500 minus 1, how many tickets is that? 499, right? 499 tickets will lose. So that is the meaning. What we are asked to do is we are asked to find the expected net gain if someone buys one ticket. So if you remember the expected value, the expected gain or expected loss, whatever you call it, but the expectation E of x is equal to sum of x times P of x. That is the formula. So what we are going to do is first we are going to create the probability distribution for gain. So I'm going to consider gain x in dollar. So that is my random variable. There is only one gain. If somebody gets the or win the ticket, then the gain will be, you can see here, the gain will be 10,000 out of 10,000, the cost is 20. So it will be 10,000 minus 20, which is $9,980. That will be the gain. So only one gain, and everybody else will have a loss. They will lose $20. Loss means minus 20. Okay, so somebody who will gain $9,980, and everybody else, they will lose $20. Now, if you find the probability P of x, your probability will be, so one ticket is gaining. Out of 500, only one of them will gain. So 1 out of 500. So the probability is 1 out of 500. And here, if one of them will gain out of 500, 499 of them will lose. 499 out of 500 will not gain. They will lose. So that is the probability. So this distribution that I have created here, this is our probability distribution. So our first step is to create the probability distribution like this. Now, after we have the probability distribution, to find the net gain, okay, expected net gain.
500 or over 15?
Over 500, yes. 499 over 500, thank you. So now the expected net gain is given by this formula. So we can write expected net gain E of x is equal to, you can see it is the sum of x times P of x. So this is x, this is P of x. We have to multiply and add them together. So 9980 times 1 over 500. So this will multiply with 1. So it will be 9980. And in the denominator, you have 500. Then you are adding this product. When you multiply this, this will be negative. So adding a negative is same as subtracting. And then here you have 20 times 499. This is what you will multiply. 20 times 499, that is 9980 again. Divided by, in the denominator, we have 500. So this is equal to, you can see here, these two are exactly the same. When you subtract the equal values, you'll get 0. So the expected gain is $0. So the expected or the mean gain here is $0. Okay, another example. In another raffle, there are many winning prizes. If you remember in the previous one, we had only one prize. But here, there are many winning prizes. One prize is $10,000. Is it $10,000? $1,000. One prize is $1,000. Another prize is $200. And there are 8 $10 gift cards. So you can see one prize will be $1,000. The other one prize will be $200. And then there are 8 $10 gift cards. And the cost of the ticket is $3. If you look at the cost of the ticket, it is $3. Cost of the ticket, $3. And they sold exactly 800 tickets. So you can see the information clearly. There are prizes. The one prize is for one ticket, they are giving $1,000. For another ticket, they are giving $200. For 8 tickets, they are giving $10 gift card. So how many tickets are getting the prize out of 800? Who can tell me? One, $1,000. One, $200. 8, $10 gift card. So how many prizes in all?
3.
10.
10, right? Because 8 $10 gift cards, that is 8. This is 9. This is 1. So 10. So they're giving out 10 tickets back. That means how many tickets are not getting the prize? Out of 800, you can see out of 800, 10 tickets are getting the prize. How many are not getting back?
790.
800 minus 10, 790. Very good. So let's make the table now for the gain. So for the gain, if we make the table, let's do gain. You can also follow along with me. Gain X, that's my random variable. And we are writing this, or we have the values in dollars. So let me write that in dollar. Now, look at the first one here. They are selling this for $3 and they are giving back $1,000. So what is the gain there? 997, right? 997 is the gain.
Yeah.
And then this one, they are selling it for $3, but they are giving back 200. So 197 is the gain. 197 is the gain. And then for the remaining 8 of them, there are 8 of them. For the remaining 8 of them, 8 times, the gain will be, they paid $3 for the ticket and they are getting back $10. So the gain is $7. So they are gaining $7 and there are 8 of them. That is the meaning. Now, if you want to find the probability, you can do it like this. You can do 8 times 7, or you can just write like this. You can just write $7 as the gain, and you can take that 8 into consideration down here. You can also do that. It is the same thing. Now the probability P of X probability. So there is one ticket gaining this. Okay, one ticket will gain 997. So it is 1 out of 800. So we can write 1 out of 800. This one, 197. Also one ticket is gaining that. So 1 out of 800. But $7 from the gift card is gained by 8 tickets. So this is 8 out of 800. It is 8 out of 800. These are the gain. These are just the gain. But everybody else will lose $3. Okay?
800 instead of 100.
8 over 800, yes. Now everybody else will lose $3, so minus 3. And you can see here we have 8 plus 1, 9 plus 1, 10. 10 tickets are given the prizes out of 800. So the remaining tickets, that is 790, will gain nothing. They will lose 790 over 800. So that is the probability distribution. So we constructed the probability distribution here. That's our probability distribution. So after we have this probability distribution, we are going to calculate the net gain or expected net gain. That's what we are calculating. So if I want to calculate the expected net gain, our formula is E of x is equal to the sum of x times P of x. That's our formula. So the expectation E of x is equal to, we multiply these values. So 997 times 1. You can also do it in your calculator, 997. Denominator is 800. The next one plus 197 times 1, that is 197 over 800. Then plus 7 times 8 in the numerator, which is 56 over 800. And the last one has a minus, so the result will be minus. Now here it is 3 times 790. You can multiply that in calculator. 3 times 790. Your result must be 2370. 2370 divided by 800. So after we have that, everything is set up. Now let's calculate this. So the expected value will be equal to, denominator is the same, so you can keep the denominator the same, 800. Now in the numerator, let's see what is there. You have 997 in the first, then plus 197, then you have plus 56, then you have minus 2370. So if you perform that, what do you get?
Negative 1,120.
Right, negative 1,120. So this will give you the average loss, because there is a negative. If you divide that 1120, if you divide that by 800, it will be 1.4. So there is an expected loss of $1.40. That is the meaning of that. So in the same lottery, in the second example or second problem we did before, where we calculate the expected value, we'll modify the winning so that the winning ticket gets to keep $3 along with the winning prize. Now see, this is quite interesting. So if somebody win, they will also get their ticket price back. That is the meaning. They get to keep that $3 if they win. And the winning prizes are, if you look at the winning prizes, the one prize is $1,000, the same $1,000. The other one is $200, and then 8 $10 gift cards. But also they get to keep those $3 with them. They are not losing this. Okay. If somebody win $1,000, they will also get their ticket price back. If they get this $200, they will also get that $3 back. If they get these 8 gift cards, they will also get that $3 back. But everybody else, they will lose that $3. So if the cost is $3, the cost of the ticket, it's the same example. So the cost is $3, and then they sold a total of 800 tickets. So let's make the probability distribution now. Let's see how it will be or what it will be this time. If you think of the gain, Let's write it down. Gain in dollar. If you look at the first one, if somebody is getting $1,000, they are gaining $1,000 because they will get that ticket price back. So it will be 1,000. The second one is if they gain $200, if they get $200, that is their gain because they will get their $3 back. If they win $10 gift card, their gain is $10 because they are getting their price back. But everybody else, they are losing $3. So that is -3. That is the gain. Now we can write the probability P of X. You can see one person will gain $1,000. One person will gain $1,000 out of 800. One person, another one will get $200. So 1 out of 800 will get $200. $10 gift card will be gained by 8 out of 800. So 8 out of 800 again. And then here you can see you have already given, or they have already given 8, 9, 10. 10 of them, they got the prizes from them. So now 790 of them will not get. So 790 out of 800 will lose that $3. So this is our probability distribution. So the probability distribution is a little bit different from the previous one because everybody who gained the ticket is getting their $3 back. So this is my probability distribution. Now we need to find the expected net gain. So if you remember, the expected net gain, E of X, is the sum of X times P of X. That is, we have to multiply these numbers, okay, and then add them together. So the first one is 1,000 times 1 over 800, which is equal to 1,000 divided by 800. Then plus, second is 200 times 1 over 800, which is 200 over 800, 200 over 800. And this one will be 10 times 8, that is 80 over 800, 80 over 800. Then we are multiplying with the negative, so it will be minus. Now it is 3 times 790. You can do that in your calculator. You should get 2370 over 800. So if you try to simplify this, you can see your denominator is 800. In the numerator, you have 1,000 plus 200, which is 1,200. 1,200 plus 80, 1,280 minus 2370, which will be negative 1,090. Very good. That is equal to negative. So if we divide this 1,090 divided by 800, you should get approximately 1.36. So there is an expected loss of $1.36 when you just buy one ticket. Let's find out what is here in this example. Determine if the given experiment can be classified as binomial experiment. If not, state why not. So here they have given 4 experiments and we have to check whether these are binomial experiments or not. If you remember the conditions for the binomial experiment, there were 4 conditions. The first one is the number of trial must be fixed. Okay, n must be fixed. That is the first thing. And each trial can have 2 outcomes only. You cannot have more than 2 outcomes. And the outcome of each trial must be independent of each other. That was the third condition. And the fourth one is the probability of success must remain the same for each trial. So here in A, let's find out, multiple choice exam consists of 60 questions with 5 possible answers, A, B, C, D, E. And the first 40 questions are, you can see on the first 40 questions, let me read it. I read something wrong. A multiple choice exam that consists of 60 questions with 5 possible answers. So there are 60 questions, okay, with 5 possible answers for first 40 and then 4 possible for last 20. So if you look here, on the first 40 questions, the probability that you'll answer it correctly is 1/5, 1 out of 5. Whereas for the last 20 questions, the probability is 1/4 because you'll answer 1 out of 4. I hope you understand that. See, for the first 40 questions here, you have the option A, B, C, D, E for the first 40 question. So the probability that you'll make it correct is 1 out of 5. Out of A, B, C, D, E, one answer is correct. And for the 20 questions there, okay, for the other 20 questions, here, the options are A, B, C, D only. So the correct answer will be 1 out of 4. So here the probability is 1 out of 4. So you can see that the probability of success should be same for all 60 questions for these to be the binomial probability experiment. So because the value of P is changing, this is not a binomial probability distribution. Okay, so your answer is no, because the value of P is not the same for all 60 questions. So you'll say no, because, make sure you write it down, because probability of success P is not the same for all 60 questions. For all 60 questions. For the experiment to be binomial, the probability of success should be same for all 60 questions. It is not the same. That's why this is not a binomial probability experiment. Let's check B now. In B, they said an algebra test with 20 questions. So there are 20 questions. The professor gives partial credit if most of the work is correct. Now, there are 20 questions. Okay, the number of trial is fixed. But the outcome is, if the outcome is either right or wrong, then it is a binomial. But here, the professor is not just giving 100% right or 100% wrong, but he is also giving partial credit. So is this a binomial experiment?
No.
No, because they are also getting the partial credit. No, because, let's write that, because the outcomes is not just right or wrong, because they are also getting credit for something in between. So that's your B. Now let's look at C. Our student did not prepare for an entrance exam consisting of 100 questions. There are 100 questions, so number of question or number of trial is fixed, okay? And all the questions are multiple choice with 6 choices, A, B, C, D, E, F. So all questions have 6 choices, meaning of that is probability of making correct is 1 out of 6 in all 100 questions. So you can see that the number of trial is also fixed, okay? Probability of success is same throughout. And then if you answer correct in the first question, the probability of answering the second, third, or fourth question does not depend on the previous question. So you can say that the outcomes are also, or the outcome of the experiment are also independent. So is this a binomial experiment?
Yes.
Yes. Yes, because it satisfies all conditions. So the answer is yes. Okay, that is C. Now let's look at D and find out what is there. In a business class, the professor gives an essay exam to discuss the benefit of financial planning, and the partial credit is available, quite similar to B. So if there is a partial credit, is this the binomial experiment? You have already answered this question, yes or no?
No.
No.
No, because the partial credit is also given, right? So the answer will be no. Okay. There we go. No, because the outcome is not just right or wrong. Example, let's see what is here. A student will be taking a quiz. He is underprepared and willing to guess answer. Okay. The quiz consists of 10 true or false questions. So you can see here, there are 10 questions. Meaning of that is n is equal to 10. Okay. Quiz consists of 10 questions. And then the outcomes are true or false. So meaning of that is n is equal to 10 and p is equal to 1 out of 2 or half. Probability of success is half. Okay, p equal to half or 0.5. You can also write 0.5. So there are 10 questions. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 questions are there. Now, the first part is we have to find the probability that he guesses exactly 7 correctly. So in the first part, we want to find this probability that x is equal to 7. X is equal to 7. If you remember, we are going to use calculator to solve this example. If you remember from the class, in order to type this in calculator for exactly 7, it should be binomial PDF, that is binomial probability distribution. First we type n, which is 10, then we type the p value 0.5, and then we type 7 because x is equal to 7. We do this in calculator. Make sure you write this down, and we are going to use calculator to solve this. So let me bring my calculator. So what we do is we press second and then vars so that we go to distribution. Please do that. Second and then vars. Then scroll down to get binomial PDF, binomial probability distribution function. This one, binomial probability distribution function, and then enter. Number of trials, n is 10. The probability of success in true or false is 0.5, so 0.5. The value of x, we said exactly 7. And then you paste this in the main screen. So this is what we wrote on paper. Binomial PDF 10, 0.5, 7. If you hit enter, what did you get? 0. Okay, I have so many number of decimals. I'm going to copy that. 1171875. I'm just copying everything. When you enter in your, when you do the mastery exercise, you should look at the number of decimals asked, and then you have to enter whatever number of decimal is asked there. Now in the second question, we have to find the probability that they answer all questions correctly. So this is probability that x is equal to 10. If they are underprepared, the probability that they will answer all 10 questions, this is unlikely. So you can think that this probability will be very close to 0, but we are going to check that in a calculator in a second. First, let's write it down. So when x is exactly equal to 10, this will be binomial probability distribution function. 10 is the total number. Probability of success is 0.5. And also the value of x is 10. Now we are going to type that in our calculator. So I'm going to share my calculator. Same as before, but here I need 10. So I'm going to copy that. I can copy like this. If I go back and select that, it is copied now. And when I enter, it will come down here. Now in place of 7, I need 10. I need 10, and then close the parenthesis and hit enter. See what I get? I get 9.765625 e to the negative 4. Whenever you see e to the negative 4, meaning of that is 0.4 zeros, okay, 0.4 zeros, and then this number, 0.4 zeros, and after that, 97659 7, 6, 5, 6, 2, 5. That is the meaning. Whenever you see e to the negative 4, first you should write 0.4 zeros and then write all these numbers. Now C. In C, we have to find the probability that at least 7 questions correctly. So now we need to know the meaning of at least. What is the meaning of at least? Who can tell me? At least 7.
7 or less.
7 or more. Okay, at least means 7 or more. If it is at most, then it will be 7 or less. But this is at least, so this is 7 or more. So we write like this: probability that X is 7 or more, greater than or equal to 7. That is the meaning of that. When I say greater than or equal to 7, I'm talking about this. These three. 7 or more means probability of 7 plus probability of 8 plus probability of 9 plus probability of 10. What we know is if we add the probability of each of these, if I make the binomial probability distribution and if I add all these probabilities down here, it will be 1. You know that. So if I do this, if I do 1 minus the probability of all these, if I do 1 minus the probability of all these, then I will get that probability. But how do I do that in calculator? This is how we do. 1 minus, the way we find the probability of all this is binomial CDF now, cumulative probability distribution, CDF. When I do CDF, it will add the probability from here all the way up to that value. We have 10 in total, 0.5, and we have to add the probability from here all the way up to 6. All the way up to 6. In fact, it even includes 0 here, probability that they don't answer any of them correctly. So from 0 up to 6 is included. Okay, so this is how we write that. Now let's find out how we can type this in calculator. 1 minus the binomial probability. Let me show you the calculator. Let's begin that typing. 1, then minus. I need the binomial CDF. So you go to second and then vars. Second and then vars. And scroll all the way down until you get binomial CDF. Look at that. Binomial cumulative distribution function. Hit enter. Number of trial you have 10. P is 0.5, probability of success. X value was up to 6. We want to add up to 6. And then paste this in the calculator. See, this is what we wrote in the paper. And hit that enter. And copy that value in your answer sheet. 0.171875. So that is the probability that at least 7 questions are answered correctly. Now we have the last part, D. No questions answered correctly. That is probability that X is equal to 0. Probability that X is equal to 0. No question is answered correctly. That is 0. So you know that this is binomial PDF because exactly 0. So 10, 0.5, and this should be 0. Please type this in your calculator now. I want you to type this one. Please type this. Okay, that is the answer. So that is for this example. Probability that no question is answered correctly is very small probability. Meaning of that is even when you're underprepared, you'll answer some question. That is the meaning of that. Let's go to next example. Another student will be taking multiple choice exam again, and C is underprepared for and willing to guess every answer. The exam consists of 20 multiple choice questions. Now you can see 20 multiple choice questions, so n equal to 20, okay? And there are 5 possible answers. 5 possible answers. So value of P will be 1 out of 5, or if you want to write in decimal, it is 0.2. We have to answer each of these questions. The first one is no questions correctly. That is probability that X is exactly equal to 0. You know that from the previous example, when you're calculating the probability like this, it will be binomial PDF. Number of trial is 20, probability is 0.2, and value of X is 0. Now you'll type this in your calculator. Please type this in your calculator. So it is 0.0115. Very good. So that is the first one, A. Now let's look at B. In B, all questions correctly. That is probability that X is exactly equal to 20. So this will be binomial PDF, 20 total, 0.2 is the probability. We are calculating the probability that all questions are answered correctly. So that will be 20. Please type that in your calculator. Don't fix your calculator to any decimal places. Just find whatever you'll get. Or in the scientific notation, it is 1.0485 857. Let me write 86 times 10 to the negative 14. Okay, so that is the meaning of that. So it's a very, very small number. That is the answer. Do you see that? So here we want to calculate the probability of answering less than 10 questions correctly. So this is probability that X is less than 10. When we say less than 10, we are looking for the probability that they answer no question or one question or two questions all the way up to 9. That means we have to add the probability from 0 up to 9. So this is the cumulative frequency. So this is binomial CDF. Okay, this is the cumulative frequency or cumulative probability. Number is 20, probability is 0.2. We want to go up to 9. That is the meaning of less than 10. Please type this in your calculator.
0.9974.
0.9974. Perfect. So that is the end of this example and everything for today.